Section 9.2 Systems of linear equations in three variables. When we're solving for the systems of linear equations in three variables, there are three different types of solutions. The first type is when you have a single solution, and that is in the format of order triple x, y, z. The second type is when you have an infinite number of solutions. That is when after the elimination, the result in an expression that is always true, such as 0 equals 0 or 10 equals 10. And the third type is when you have no solution at all. That is when after elimination, you have a contradiction statement, such as 3 equals 0 or 5 equals 10. Example 1. Find a solution of the following system. I have three different equations in three different variables, and my job is looking for the values of x, y, and z that satisfy all of these three equations. So I will call this equation 1, this equation 2, and this equation 3. I have equation 1, equation 2, and equation 3. From section 9.1, I have learned how to solve the system of two equations and two unknowns. In this section, I have three equations and three unknowns. If I can eliminate one of the variables to turn that into the system of two equations and two unknowns, I would be able to solve for it. So the first step I'm going to do is trying to eliminate one of the variables. You can either eliminate x or y or z. That is totally up to you. But from looking at the coefficients of x, I think that will be easier for us to eliminate x. Step 1, I will combine my first and the second equation in order to eliminate my x. My equation 1 is x minus 2y plus 3z equals 9. And equation 2 is negative x plus 3y minus z equals negative 6. If I add the two equations now, x will be eliminated. Negative 2y plus 3y is y. 3z plus negative z is 2z. 9 plus negative 6 is 3. So I have y plus 2z equals 3. I end up with one equation and two unknowns, and I call this equation 4. Next, I will need to create an equation 5 that is also in terms of y and z. I already used the combination between 1 and 2 to create the equation 4. So to create the equation 5, I cannot use 1 and 2 anymore. I can use either 1 and 3 or 2 and 3. So in this case, I am going to use 2 and 3. My equation 2 is negative x plus 3y minus z equals negative 6. And my equation 3 is 2x minus 5y plus 5z equals 17. Remember, in step 1, I eliminated x. In step 2, I also have to eliminate x. So I want to eliminate x right here. This one is negative 1 and this is positive 2. I want to turn this into negative 2. So what I'm going to do is multiply both sides by 2. So I have negative 2x plus 6y minus 2z equals negative 12. And my equation 3 stays the same. 2x minus 5y plus 5z equals 17. And I am going to add the two equations. Negative 2 plus 2 is 0. 6y plus negative 5y is y. Negative 2z plus 5z is 3z. Negative 12 plus 17 is 5. So I have y plus 3z equals 5. And I call this equation 5. Now, I am going to pair equation 4 and equation 5 to have a system of two equations and two unknowns. My equation 4 is y plus 2z equals 3. Equation 5 is y plus 3z equals 5. I have the system of two equations and two unknowns. To solve for y and z, I can use either substitution method or addition method. In this case, I am going to use addition method. I want to eliminate y. So this coefficient is 1 and this coefficient is also 1. I want them to be opposite. So I'm going to multiply the fourth equation by negative 1 on both sides. I have negative y minus 2z equals negative 3. And my equation 5 stays the same. Y plus 3z equals 5. And I am going to add the two equations. Negative y plus y is 0. Negative 2z plus 3z is 1z. Negative 3 plus 5 is 2. I found z equals 2. The question is asking me to find x, y, and z. I found z. Z is equal to 2. The next step, I am going to use equation 4 or equation 5 in order to solve for y. It doesn't matter if you use equation 4 or 5. As long as you substitute 2 in for z, you will get exactly the same y. I am going to use equation 5 and I will substitute 2 in for z. So I have y plus 3 times z equals 5 and z is equal to 2. So I have y plus 6 equals 5. And if I subtract 6 from both sides, I have y equals negative 1. So I found z and y. Next, I will need to use either equation 1 or 2 or 3 in order to solve for x. It doesn't matter if you use equation 1 or 2 or 3. As long as you substitute negative 1 in for y and 2 in for z, you will get to exactly the same x. In this case, I am going to use equation 1. My first equation is x minus 2y plus 3z equals 9. I am going to substitute negative 1 in for y and 2 in for z. X minus 2y plus 3z equals 9. Y is negative 1 and z is 2. Negative 2 times negative 1 is 2. And 2 times 3 is 6. 2 plus 6 is 8. And if I subtract 8 from both sides, I have x equals 1. So I found x, y, and z. Now I am going to put the answer in the order triple. So in the order triple, you have three components, x, y, z. So I'm going to have 1, -1, and 2. Example 2. John invested his inheritance of $12,000 in 3 different funds. Part in a money market fund paying 3% interest annually, part in municipal bonds paying 4% annually, and the rest in mutual funds paying 7% annually. John invested $4,000 more in mutual funds than he invested in municipal bonds. The total interest earned in 1 year was $670. How much did he invest in each type of fund? The question is asking me, how much did he invest in each type of fund? I have 3 different types. The first one is the money market fund. The second one is municipal bonds. And the third one is the mutual funds. I don't know how much he put in each of these, but I know that the total he invested is $12,000. So I have 3 different unknowns: the money market fund, the bonds, and the mutual funds. So I am going to organize all of these information in a table. I have 3 different funds, so I put them in 3 different categories. The next information that I need to put into this table is how much that John invested. I don't know how much John invested in each fund, but I know the total is $12,000. The next information that I want to organize in this table is the interest rate. The interest rate for money market is 3%. And I want to convert that into decimal. I'll take 3 divided by 100. I get 0.03. The interest rate for the bond is 4%, which is equivalent to 0.04. And the interest rate for the mutual fund is 7%, which is equivalent to 0.07. The next information that I want to put into the table is the amount of interest that John collected in 1 year. From here, they told me that the total interest earned in 1 year was $670. I don't know how much interest he earned in each fund, but I know the total was $670. So these are all the informations that they gave me. Now, these are the ones that I don't know. So the unknowns are the amount that he invested in the money market, the amount that he invested in the bonds, and the amount that he invested in the mutual fund. I have 3 unknowns, so I call them X, Y, Z. You can call them any other letters that you want to. It can be A, B, C. It doesn't matter. And I know that the total amount of money that he invested is $12,000. So if I take X plus Y plus Z, that should be equal to $12,000. This is my first equation. So this is the amount that I invested. In order to calculate the interest that I collect in 1 year, I'll take the amount I invested multiplied by the interest rate to get to the interest earned. So I have X times 0.03, which is 0.03X. And for the bonds, I'll take Y times 0.04. I get 0.04Y. And for the mutual fund, I take Z times 0.07, 0.07Z. 0.03x is the interest earned for the money market fund. 0.04y is the interest earned from the bonds, and 0.07z is the interest earned from the mutual funds. And I know that if I add these three up, I get 670. So this is my second equation. And from this sentence, they say John invested $4,000 more in the mutual funds than he invested in the bonds. What does that mean? It means that for whatever amount that he invested in the bonds, he will invest $4,000 more in the mutual fund. So basically, Z is $4,000 more than Y. So Z is equal to Y plus 4,000. And that is my equation 3. I have the system of 3 equations and 3 unknowns, and I'm looking for the value of x, y, and z. However, from my third equation, I know that z is equal to y plus 4,000. So basically, I can substitute this z and this z with y plus 4,000. So I have my equation 1 and equation 2. I will substitute z with y plus 4,000, and I will substitute this z with y plus 4,000. And I will need to simplify this equation. I have y plus y is 2y. So I have x plus 2y plus 4,000 equals 12,000. And if I subtract the 4,000 from both sides, I will have x plus 2y equals 8,000. This is my new equation 1. Next, I will substitute this z with y plus 4,000. To simplify this, I will need to distribute 0.07 out. I have 0.07 times y and 0.07 times 4,000, which is 280. Combining like terms, I will have 0.11y. And if I subtract 280 from both sides, I will have 390. This is my new equation 2. Now I can leave it like this. However, later on I will need to use the addition method. So I would prefer to deal with whole number rather than decimals. So in order to turn this 0.03 to a whole number, I need to move the decimal point to the right 2 places. That means I need to multiply both sides of this equation by 100. So I have 3x plus 11y equals 39,000. This is my new equation 2. Next, I will pair the new equation 1 with the new equation 2 to have the system of 2 equations and 2 unknowns. I need to move to the next page, so I will show you how to do that on the new page. So I have the system of 2 equations and 2 unknowns, and I want to solve for both x and y. I can use either substitution or addition method. I will use addition method in this case, and I want to eliminate x. In order to eliminate x, I need this coefficient to be -3. So I'm going to multiply both sides of this equation by -3. So I have -3x minus 6y equals -24,000. And the second equation stays the same. 3x plus 11y equals 39,000. From here, I'll add the 2 equations. Negative 3x plus 3x is gone. Negative 6y plus 11y is 5y equals negative 24,000 plus 39,000 is 15,000. And then I'll divide both sides by 5. Y equals 3,000. Y is the amount of money that John invested in bonds. And remember, the amount that he invested in mutual funds was $4,000 more than Y. So how much did he invest in mutual fund? I will use this equation 3, Z equals Y plus 4,000 in order to solve for Z. I have Z equals Y plus 4,000 and I know that Y is equal to 3,000. So I will substitute 3,000 in for Y. Z is 3,000 plus 4,000, which is 7,000. Z is the amount of money that John invested in the mutual funds. So he invested $7,000 in mutual funds, $3,000 in bonds. How much did he invest in the money market fund? I will use the first equation, x plus y plus z equals 12, to solve for x. My first equation is x plus y plus z equals 12. I will substitute $3,000 in for y and $7,000 in for z to solve for x. So I have x plus $3,000 plus $7,000 equals $12,000. $3,000 plus $7,000 is $10,000. So x plus 10,000 equals 12,000. And if I subtract 10,000 from both sides, x is 2,000. I found x, y, and z. X is the amount that John invested in the money market fund. Y is the amount that John invested in the bonds. And Z is the amount that John invested in mutual funds. Example 3. Solve the following system. I have x minus 3y plus z equals 4. Negative x plus 2y minus 5z equals 3. 5x minus 13y plus 13z equals 8. I have 3 equations and 3 unknowns, and I'm looking for x, y, and z. So I call this equation 1, this equation 2, and this equation 3. Next, I want to create the equation 4 and equation 5 in 2 variables. So I have to eliminate one of the variables. By looking at the coefficients, I think x will be the best choice. I will try to eliminate x. So for equation 4, I will combine equation 1 and 2. I am going to add the 2 equations in order to eliminate x. X plus negative x is 0. Negative 3y plus 2y is negative y. Z plus negative 5z is negative 4z. 4 plus 3 is 7. This is equation 4. Equation 4 is in terms of y and z. equation 5 must be also in terms of y and z as well. I already used the combination of 1 and 2 for equation 4. So for equation 5, I can use 1 and 3 or 2 and 3. In this case, I am going to use 2 and 3. So this is my equation 2 and this is my equation 3. I want to combine these two equations to eliminate x. So in order for x to be eliminated, the coefficients must be opposite. So this coefficient is 5. I need this coefficient to be negative 5. So I will multiply both sides of the equation 2 by 5. So I have negative 5x plus 10y minus 25z equals 15. And the other equation stays the same. 5x minus 13y plus 13z equals 8. And I am going to add the two equations. Negative 5x plus 5x is 0. 10y plus negative 13y is negative 3y. Negative 25z plus 13z is negative 12z equals 15 plus 8 is 23. This is my equation 5. So, always making sure equation 4 and equation 5 always have the same variables. Equation 4 has y and z. Equation 5 also has y and z. Now I am going to pair these two equations. Now I have the system of two equations and two unknowns, and I am going to solve for y and z. I can use either the substitution method or the addition method. I will use the addition method in this case. I want to eliminate y. In order to eliminate y, the coefficient needs to be opposite. So for example, this coefficient is negative 3, then this coefficient must be positive 3. So in order to turn negative 1 into positive 3, I need to multiply by negative 3, and I have to do it on both sides of the equation. So I have 3y plus 12z equals negative 21. The other equation stays the same. Negative 3y minus 12z equals 23. And I am going to add the two equations. 3y plus negative 3y is 0. 12z plus negative 12z is also 0. So on the left-hand side, I have 0. On the right-hand side, I have negative 21 plus 23. This is 2. So I end up with a statement saying that 0 equals 2. I don't agree with this statement because this is a false statement. So we call this a contradiction. When we have a contradiction statement, that means the system of equations is inconsistent. Therefore, the system has no solution. Or you can also call it D and E. Example 4. Find the solution to the given system of 3 equations in 3 variables. I have 2x plus y minus 3z equals 0, 4x plus 2y minus 6z equals 0, x minus y plus z equals 0. So I call this equation 1, this equation 2, and this equation 3. The first thing I'm going to do is trying to eliminate one of the variables so that I can have the system of 2 equations and 2 unknowns. By looking at the coefficients of these variables, I think eliminating y is the best choice. So step 1, I will combine equation 1 and equation 3 in order to eliminate y. The coefficient of this y is positive 1 and the coefficient of this y is negative 1. So if I add the two equations, y will be eliminated. And I have 3x minus 2z equals 0. And I call this equation 4. Next, I have to create equation 5 in terms of x and z. I have used equation 1 and 3 for equation 4. So for equation 5, I can either use a combination of 1 and 2 or 2 and 3. I think I am going to use 2 and 3. So remember, we need to eliminate y because we want our fifth equation in terms of x and z. So this coefficient is 2 and this coefficient is negative 1. I want the coefficients to be opposite. So I need this to be negative 2. So I'm going to multiply both sides of this equation by 2. So I have 2x minus 2y plus 2z equals 0. And the other equation stays the same. And if I add these two equations, the 2y plus negative 2y is cancelled out. And I have 6x minus 4z equals 0. And this is my equation 5. So equation 4 and equation 5 are in terms of x and z. Now I'm going to pair these two equations. After putting the equations 4 and 5 together, I have the system of two equations and two unknowns. And I will have to solve for both x and z. You can either use the substitution method or the addition method, it doesn't matter. I will use the addition method in this case, and I want to eliminate x. In order to eliminate x, I need the coefficients to be opposite. This coefficient is 6. I want this to be negative 6. So in order to turn 3 into negative 6, I need to multiply by negative 2. So I will multiply both sides of this equation by negative 2. So I have negative 6x plus 4z equals 0. And the other equation stays the same. 6x minus 4z equals 0. And I am going to add the two equations. Negative 6x plus 6x is 0. 4z plus negative 4z is also 0. On my left-hand side, I have 0 equals. On the right-hand side, I have 0 plus 0 is also 0. In this case, I have a statement saying that 0 is equal to 0, which is true. This is called an identity, where you have a true statement. That means this system has an infinite number of solutions. And I want to put the solution in general form. My general solution is in the format of the order triple, where you have x, y, and z. Your first coordinate is x, and you want to turn y and z into an expression in terms of x. So in order to do that, I would use either equation 4 or 5 and solve for z. So I'm going to use equation 4. I'm out of room, so I'm going to show you how to solve for z on this page. I use my equation 4. 3x minus 2z equals 0. To solve for z, I'm going to bring the negative 2z to the right side. So I add 2z to both sides. And I have 3x equals 2z. I have 3x equals 2z. To solve for z, I need to divide this by 2. So I am going to divide both sides of this equation by 2. So 2 canceled out. I have z equals 3/2 x. So I know z is equal to 3 over 2 times x. So in my order triple here, this is where z is. I will replace it with 3/2 x. And I need to find the expression for y. In order to do that, you need to use one of these 3 equations to solve for y. It doesn't matter which one, but I am going to use the third equation. I have x minus y plus z equals 0. And remember, I found z was 3/2 x. So I am going to replace this z by 3/2 x. And I am going to combine this x with 3/2 x. So 1x plus 3/2 x is 5/2 x. And to solve for y, I am going to add y to both sides. So this y canceled out. I have 5/2 x equals y. So I found that y is equivalent to 5/2 x. I am going to put this into my order triple. So I have x, y, z, and y is 5/2 x. I will put 5/2 x in here. And this is my solution in general form.